Now starting. All attendees are in listen-only mode.
Hello everyone, this is Sandeep here. Are you able to hear me and see my screen clearly? All right. All right. So there were some confusions because for some people the link did not reach. The reason was the email might be going in the spam. All right. So we will fix those problems, and in the tomorrow session we'll fix those problems. Also, if you do not see in your courses when you click on my courses, if you do not see your course as in this particular course in the session, okay, please let us know. Okay, this is the course. All right, so this is the course. So because lots of people have tried to move from one session to another, so there is a little bit confusion amongst who is in which session. All right, so please let us know if you are able to see this course page. It has all the details that are required. All right. All right. So let's jump in. We are already running around 12 minutes late. So hello Bala. Hi Srini. Hello Randhir. All right. And all right. And great. Great. So everybody in. If you have any questions before we start our next session, please let me know. All right. We will start from the point we had left. Okay. Hello, Naveen Gupta. All right. So before we start, is everybody comfortable? And Sridhar, it should the recorded session should appear here in the My Courses. Do you see in the My Courses this part, 17th October 1? So this is where yesterday's session would be. Yes, Susant, I can see your messages. All right. All right, great. There was a question from Randhir. It is showing 17th October. Do I have the correct link? Yes, you have the correct link. 17th October just means that the course, that's a course starting date. So Sridhar's question is, but I saw all 11 recorded sessions already. So most of these recorded sessions were the old sessions, meaning the previous ones. Okay, these are old recorded sessions. All right, these are the old recorded sessions, and the one which are here, they are the new ones. All right, the Susan's question is, the questions from yesterday, will they be emailed later? You mean the notes? The notes will be added here itself. Okay, the notes, whatever I make, the notes, they will appear here in the session 1, session 2, and so on. Great. All right. All right. So Vinay is saying that in my recorded sessions, I could not see yesterday's. So when you see my recorded session, does it say 17th October, 8:30 p.m.? All right. Just let me know if yours need to be fixed, because there have been some movement from various people into different courses. That's why there is a slight confusion. All right. All right. So I'll fix all of this. Just drop me an email at reach us, or you can just drop me an email at Hadoop at no big data, and then I'll fix it. Okay. At any of the email IDs. All right. So great, great. All right. So apologies for the little mismanagement. We will take care of this in future, and this is not going to be repeated. All right. Good. All right. Now, yesterday we had discussed about the whole architecture of Hadoop, the ecosystem, what all components does it have. All right. So we talked about it yesterday. Today, today we will take it from further, and we will start with our main component. The main component is HDFS. All right, we will deep dive into HDFS, as in how does it function and how do we work with HDFS. All right. So any questions related to the Hadoop ecosystem, where we had these components and there were many other descriptions which we had given. All right, let's jump in. The In case I forget to start recording, please remind me. If you don't see the session is being recorded at the bottom of the GoToWebinar, kindly remind me. Okay. All right. All right. So here is the question for all of you. Today we are going to derive, as in deduce, how did people reach to this HDFS and what is the point of using such a system. Let's imagine for a time being that you decided to build a storage of 100 terabyte. How would you so you how would you build such a storage? Or let me put it this way, you decided that you and your friends or in your hostel that you will need 100 terabyte of storage to store all the movies. Okay, so you plan to build 100 terabyte of storage. How would you go about it? What all things will you do? Okay. Bala's question is, where do we see the recording icon? Recording icon would be on the GoToWebinar bottom, where it will show you the session is getting recorded. Okay. So I'll always start the session recording. In case I forget, this message will not appear, and please remind me in that case. All right. So the answer to this question, please focus on this. So if you have 100 terabyte of data, how are you going to build the storage to store 100 terabyte? All right. Please feel free to answer this, and we will. So Ganpati is saying multiple servers, one main to coordinate the same. Okay. Okay. Ganpati, good answer. Please go into the details. I want to know more. Srini is saying explore cloud infrastructure. The problem with cloud infrastructure is that we will have the cloud infrastructure, and whenever we need it, we'll have to make a trip. We will our bandwidth is going to be really slow. So we don't want to go ahead with this. Or let me put it this way: you are building the cloud infrastructure at your own. Okay. All right. Bala is suggesting to have a SAN storage and shared between server. Good. John is saying divide 100 TB into X servers and run a RAID 2 or 3 on them. Good. Randhir is saying we will need multiple computers and save specific files to various computers. All right. Good. Good. So, all right. All right. So, any other ideas? I would definitely like to understand more ideas because there are few more things possible for the storage. All right. All right. How do you? All right. John says that torrent-like system. Sushant suggests that I'll have grid-like structure. Great, great answers. All right, all right. Now, the very good answers. A common solution, and this is how we earlier build it, that we would build a network attached storage or storage area network, SAN or NAS. Okay, all right. So this is how we actually build in 1999 and 2000, that we bought lot of hard disk, connected them in the network. Either we house multiple hard disks into one computer, connect these computers to the network such that all the hard disks are visible in the network. Okay, and once all the hard disks are visible in the network, what you do is you you basically mount them on the folders. Have you tried mounting a remote hard disk as a drive in your computer? So in the same manner, we mount these hard disks on one computer or maybe on multiple computers so that all these hard disks are available, uh, like different folders in a single system. All right. When people try to write to the folder, the data is going to a different hard disk. All right. So the way it will look to the user is there is a main folder under which there are subfolder. Now, question to all of you is, do you see any problems with this? Is there any problem with this kind of structure where you have a main folder and there are subfolders under that main folder? Yes. Sushant's question is, will not a single computer be loaded and it would be slow accessing? Good point. So a single computer definitely would get overloaded, but then we will do this mounting thing on all computers so that in case one computer is not available, only those hard disks which are mounted on that computer will not be available, rest will be available. But good point. Yes, that's a good point. Ravi's question point is searching will be an issue. Brilliant. Veena says accessing data takes time. Perfect. John suggests that failover issues would be there. Good, good. Keep going. Uh, and very, very good points. Location of files would be difficult as hard to find which drive is loaded. All right. Meaning, Sini's point is the location of file would be difficult to find. Okay, and it's difficult to basically locate which file is where. So you will have to come up with a plan. You'll have to come up with a plan that this so movie, let's say you are building this storage for movies, so you will have to come up with a plan that okay, all the movies starting with A go to this folder, all the movies go starting with B go to the other folder, and so on. Or a better way is that we build an index, and based on the index keep we keep moving the files across. All right. Good, very good. Sushant is suggesting indexing. Yes, 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 Ravi. We would have. All right, all right. Are you able to hear me now? All right. Are you able to hear me now? All right. Hi. So there was a little glitch for a second in the internet connection, because of which the network was lost. I think now it's audible to everybody. Good. Now coming back to the point which we were talking about. All right. There's a one interesting answer from Randhir that write will be slow. Good, very good. Sushant also suggests that there will be a slow speed. Okay, all right. So yes. So if I combine your answers of all of you, this is what it comes to. And there are a few more points. First is in this kind of network, what happens is in case one computer is disconnected from the network, or one computer gets disconnected from the network, or the cable is cut by mice, or there's a hardware issues on one machine, or hard disk gets damaged. In all these circumstances, what happens is the data is completely lost. Now you might suggest that on each computer we set up the backup, but that doesn't defend. Although setting up a backup on each computer such that every hard disk is replicated does solve the problem due to hard disk failure, but it doesn't defend against the failure due to the network connectivity, or failure due to operating system, failure due to any other region on the single node. Okay, so this basically this architecture, even if we put a RAID 2 or RAID 3 or whatever, it is not going to defend against the computer problem or the node goes down. All right. So neither we have the failover nor we have the backup. There are difference between failover and backup. Failover means in case one machine goes down, the system moves to another machine and the data is available. Backup means although the although the machine is not available right now, but we may be able to recover the data. So there is a backup. All right. Second is, how would you distribute data uniformly? In this architecture, whatever plan do you come up with? Let's say you come up with an indexing plan that let's put movie starting with a particular letter. Okay, let's put all the movies starting with A in first computer, starting with B in the second, starting with C in the third, and so on. But it won't solve your problem, because there will be too many movies starting with A. There will be too many movies starting with the, and so on. Therefore, those computers which have those letters will be overloaded. And no matter how you organize, there will always be a chance of non-uniform distribution. Okay, which means some of the hard disks will fill very fast and some will be very free, and continuously we'll always be under the struggle of moving data back and forth from one computer to another in order to distribute. Okay, and now you can probably when you go back and if you remember the days when you have multiple hard disks, C colon, D colon, E colon, and you tried to manage put the movies, always there were, you were always under the struggle of moving data between one hard disk to another. Now, is this the best value for money? We are buying really high-end hard drives, such as of 1 terabyte. If we go with the existing hardware, we again have more probability of failure, and therefore we would not like to go with the existing hardware, right? And therefore, my question is, although you will be having existing hardware of smaller hard drives, and you wouldn't go with them, because in case you go with a smaller hard drive, you will have more computers to manage and therefore more problems. So, is this the best value for money? Are you buying right size of hard disk at right price? Next is this the best use of resources? Same thing. You might have hundreds of smaller hard disks already available to you. What about increasing accessibility? This is a very important point to all of you. Now, this is a, okay, correct. John says that RAID systems will provide backup and not failover. Perfect. Yes. Now, uh, this is an important point. What about increasing accessibility? Imagine this. Today is Independence Day and everybody wants to watch the same movie. Which means if the movie is stored on a computer, so everybody is going to access the computer from that, access the movie from that computer, and therefore that computer will be horribly busy. And inadvertently it will fail. That hard disk will fail, and will no longer be able to access the data. So accessibility issues would be there. All right. So accessibility issues would be there on the on in such kind of network, because hard drive has the physical restriction, because there's a header that moves from one point to another to retrieve the data, and therefore there's a physical movement, and effectively hard disk is not a great medium. And And therefore, since there is only one hard disk containing a movie, effectively everybody is trying to throttle each other. Okay, so the next point is, what about scaling out? What does it mean by scaling out? Scaling out means adding more. drives. Today we have the need of 100 terabyte. Tomorrow we might need 150 terabyte. So if you buy 150 terabyte, are you going to restructure? Are you going to move? Are you going to rebalance all the data to the new space so that there is a uniform distribution? So in this architecture, we'll have to do all of this today. Okay. Sridhar's question is, what about security since increasing accessibility? Yes. So Sridhar is saying, what about security since increasing accessibility? Because whenever we talk about accessibility, accessibility is a part of the definition of security. In case we are not able to provide accessibility, it's we are not able to provide security. So effectively, whenever we say that we are not able to provide the access to the data, it's considered as we have compromised on security. I think that's what you meant, Sridhar. Great, great. All right. Now moving ahead, then what do we do? And these are the reasons why HDFS was created. And all these points, if you keep in mind, all of these points, starting with failover, backup, distribution of data, and the best value for money, increasing accessibility, and scaling out. These are all different points. So in all, these are five main reasons. And we will see how does our HDFS solve these problems. Okay, we will visit this slide again after understanding HDFS. All right, great. All right, so let's pay a little attention to the architecture of HDFS. So in HDFS, if you have a look at this, an HDFS is comprised of two kinds of systems. One is called admin node and rest are called data nodes. Okay, so admin node or name node is like the king. It's a singular system. It's a single machine. It's a separate one single entity. There cannot be two name nodes. While there can be as many data node as there are machines. So you have bought say 50 machines. One of them will be marked as name node, and rest 49 will be the data node. While the admin node or name node, we'll just call it name node. Okay. So while the name node keeps the index of data, as in what is where. Some of you already suggested that let's keep an index when we were discussing the previous problem. Let's keep an index, and that's exactly what this admin node does. That's what name node does. Name node keeps track of what file or what data is where. So name node stores the metadata. Metadata means data of data, meaning the information about files. Which file is where? That's what is the information name node is carrying. Now all of these things, whether name node or data node, they are processes. Just like any service, the way email service keeps running in the background listening to the emails on the server so that it can deliver to various users. Similarly, there's a web service which keeps running so that it can cater to your requests. In the same manner, name node keeps running as a process, listening on a port. Similarly, data node keeps listening. All of these are just the processes. And theoretically, you can run name node and data node all together. Okay, that's what when you download these virtual machines for exercises, they have data node and name node on the same. And sometimes it's okay to have both of them on the same machine. All right. Now data node stores the actual data, and one more thing is that name node stores all this metadata in the RAM, so that it can cater to the request in a really fast manner, because name node is singular and therefore it will have lot of loads. So whenever somebody wants data, it first goes to the name node redirects the user to individual data node. In case in case somebody wants to modify the data, they first tell the name node and then they modify. Now going ahead, so let me all right. All right, I will answer your questions after finishing these 2 to 3 slides. So those questions which are irrelevant right now, I'm just skipping them and will try to answer later. All right. Now the the little bit more details about data nodes. Now these data nodes store the data. Now there's one more thing they do cleverly. They store the data in chunks. They don't store the whole file as such. They break. So whenever you want to store a file in HDFS, you this file is broken down into blocks, and then it's stored on each individual node. And when the file is being responded to you, the data gets assembled as and when you are accessing the data. So the files are split into a chunk of 128 MB blocks. Earlier, this size was 64 MB. Now it is 128 MB. It helps fitting the big files into small disks, leaves less unused space on the disk. Also, it optimizes the data transfer. It optimizes the data transfer in the sense that if we are moving a file from one machine to another, it could happen that some of the blocks move from one machine to a machine, and the rest move to some other machines. Okay, so this optimizes the data transfer and it distributes the load to multiple machines. Now here is an interesting idea. So there are many problems this breaking down into blocks has solved. First, it has made it possible to balance to distribute the load uniformly in the cluster. That is the first thing. Second, the problem which we earlier talked about is scaling out. Today we have 3 nodes, tomorrow we might have 4 data nodes, and to move to the new data node, we just have to move some of the blocks to the new node, and automatically the data will be rebalanced. Now, third thing it has made possible is, in case you have old smaller hard disks, these smaller hard disks are of say a smaller size of say 80 gigabyte, and you are trying to store a file of 81 gigabyte that of course cannot fit into this hard disk, right, in general. And those kind of problems are resolved by breaking the file into the blocks. Okay, now there is one interesting idea here. Every block which is stored on these computers is having 2 more copies, is having more than 1 copies. Generally, all right, so each block in the data node has multiple copies, and it's called replication factor. By default, the replication factor is 3, and this is what makes it possible for the backup as well as failover. Let's imagine that one of the data node is dead. So all the blocks on this data node have disappeared, right? There is a loss, but it's not a disaster because all the blocks have two more copies left in the network. So before those two more copies are disappearing, or any of other node get destroyed, those two more copies are replicated on one more node, and so that the replication factor is again brought back to 3. Now, this replication factor can be specified by default. Right now, what we have done is, in case of solid state hard drives, we have realized that the chance of failure is low. Therefore, we have marked the SSD, on the SSD, the default replication factor is 2, while on normal hard drives, we mark it, if we have the cluster set up on normal hard drives, we mark it as 3. But it's a better practice to have the backup as 3. Why? This is an important question. Why do we need a replication factor of 3? Let me ask you a simple question. How much would you keep? General answer is that we will just keep 2, right? But here is a greater danger than your normal file system. The greater danger is because we have broken a file into blocks, and and a single machine is having files from more, I mean, single machine is having blocks from many files, right? Therefore, there is a great disaster that could happen. A loss of a single machine will impact lots of files, because it will have one block from almost all the files, right? And therefore, in case one node goes down, almost all the files in the file system are impacted. So the danger is bigger. Therefore, rather than having a replication factor of 2, we keep 3. All right. So 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 the moment one node is lost, the 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 replication factor is reduced to 2, and to bring back the replication factor to 3, the data is copied to one more node, and that's the way, and that's how it rebalances. All right. So this is the HDFS replication. Now there is two more ideas, and after this I'll take up your questions. All right. Now a common question is the name node bottleneck? Is the name node bottleneck? Yes and no. Let me first clear that this diagram is wrong. This is not how it is. The way we have always imagined is, there is always a router, and whenever we have to access something, it comes through the router. Okay, so the data as it looks like it's coming through the name node. No. Instead, the architecture is like this. The user has something called a client or a driver. You can think of a command line which helps the user to copy the data from one place to another, whether to download the data, upload the data, edit the data, or append to the data. So the user has got a command to do that. Now this is called client slash driver. Now user asks client driver that, hey, I want to upload a file. The request goes to the name node that, hey, this user wants to upload the file. Now, name node, instead of accepting the data from the user, it tells the user back that, hey, this is the list of data nodes. Please go to each individual data node and write to them parallelly. So, and you put, so name node also tells the client that, hey, put the first block on the first data node, second block on second data node, and third block on third data node. And do not bother me until you are done with writing. As soon as you are done with the writing of the data, let me know so that I commit the file. Okay, so it creates an entry, dirty entry for a file which is not accessible yet. If somebody else tries to create a similar file, say files with the same name, it would not allow that. Okay, so basically Namenode just does the main work of kind of being the um, traffic police. It makes sure that nobody else is writing the same file parallelly. Second, it does not it it makes sure that in case the user is coming back to ask for a file, it will give them, it will not transfer the data through it. Let's say, now that was about writing example. In case the user wants to read the data, they, instead of going directly to the name node. Okay, so let's just walk through an example. So let's say you are downloading a movie, you are trying to watch a movie, and you are the client. So what you do is you ask name node, hey, I am interested in watching this particular movie, can you give me the movie? Okay, that's what you tell the driver. Now driver goes to the name node. Name node tells, hey, you're interested in watching the movie, here is the address of the name node and the block id. You go to the individual data node, sorry, name node tells the driver that, hey, this is the data node containing the block, you talk to this data node and get the block, do not bother me anymore. Now data node will start giving the blocks to the driver, and this user will be happily watching the movie. Okay, and as you can notice that as the user is watching the movie from a beginning till end, the transport will happen between different data nodes. All right, so therefore the name node is not generally the bottleneck, but yes, it is the bottleneck in some cases. The same example of the dynamics is depicted in the next one. All right, Sridhar's question is, who is responsible to increase in nodes on cluster? Good point. So right now, HDFS does not automatically scale, meaning it does not automatically add computers to the network. It is generally people who do that. Also, there are file systems from third parties. Okay, there are third parties who provide the file system which keep on increasing the disk size automatically by adding more and more data nodes based on the demand. All right, very good set of question. Now Arzang's question is, so the problem here would be that the admin node will be the bottleneck, right? So Arzang, does that answer your question? Have I answered your question already? Great. Now Bala's question is, this means the name node is very important server. If it goes down, what happens? All right, let me answer this one. All right. Mm, So this diagram, I have already made it clear. All right, we will take up more questions after this. I'll try to answer what Bala has asked, and probably most of your questions will be answered by that time. All right, I'm really happy to see your questions. They are exactly the way I had planned. All right, so here is the diagram which shows that there is a name node. This is the name node containing the metadata saying this is my file having these many replica promised. This is the number of replicas which is promised to this particular file, and so on. So this is the metadata. All right, and these are my data nodes. You see, in each of the data nodes, these are the blocks. Okay, one more thing, whenever we user comes in and tries to write the data, so let's say this is the client, it went to the name node saying, hey, I want to create this file. Name node tells the client that, hey, don't bother me with writing stuff, you told me the file name, I'm happy, I have made a note of it, why don't you go to the individual data node and start writing there? So client writes to individual data node in parallel. Okay, so a file is being written parallelly on two different machines at the same time. At the same time, these blocks will get replicated on between the data nodes itself. The client does not have to create multiple blocks. The block replication happens by HDFS automatically, by data nodes talking to each other. All right. So when client comes in, the client is given the address of the data node, which is very closer to the client, and client will write to the closest node possible. And based on that, the replications will happen. All right, that is the architecture diagram. I have already explained it to you. The way writes happen, user comes in, tells this client, distributed file system client, and this basically goes to the name node makes an entry that, hey, somebody is trying to create a file, and redirects back and tells that, why don't you go to the data node and write it. So the the HDFS HDFS client asks the file system to start creating the data and uploads the data. And once that is done, the replication between data nodes start happening. And once that finishes, the commit or the complete information goes to the name node that, hey, we are done writing to the data nodes, so our file is committed. Okay. Similar is the anatomy of file read. The client comes in, talks to the distributed file system, and the distributed file system talks to the name node, and it gets the block location. And these block locations, the client has got the block locations, it goes to the individual data nodes and retrieves those blocks. Now, interesting aspect here is that the user can get different blocks from different nodes parallelly. It's not a sequential process. Okay, which means the reading of file has suddenly become faster. If you have 15 hard drives and your single file is on 15 different machines, you will get parallelly 15 blocks, and happily it will be the total read speed will be the 15 times. Okay. All right, now the question which Bala has asked, that is is name node the single point of failure? Okay, name node is single point of failure. So one of the ideas that have worked with name node is name node keeps metadata in the local storage and in the network file system. Okay, so that in case local storage goes down, somebody else can become the name node reading from the network file system. All right, so the better idea is to have, earlier in the HDFS 1, there was an idea of secondary name node. In case one name node goes down, secondary name node would be brought up manually by reading the data from the file system and applying all the edit logs. So generally the data is of two forms. One is a snapshot of the name node plus the edit logs. So by combining a periodic snapshot along with the edit logs, you will be able to recover the name node. But this model was not successful because it involved the manual intervention to bring the name node up, and therefore it was not suggested. It was not at all suggested. In case your name node goes down, everything goes down. Therefore, this kind of mechanism was not acceptable. Instead, this was acceptable. So there was name node and the standby of the name node. So basically, there is a proxy for the master, and master is always updated with whatever. So proxy of the master contains always the same data. So you can imagine this. Here are name node and standby of name node. All right, and all the data nodes are talking to both. Whatever information a client sends to the name node, it sends to the standby as well. That's by design. Whenever data node is has finished moving or replicating data between machines, it not only informs name node but also informs the standby, so that both name node and standby always have exactly same data. And the moment name node goes down, standby becomes the name node. Okay, and in the meantime administrator will have a look at what exactly went wrong with name node. Is the hard disk burned? Is there real physical failure? And in the meantime, what admin will do is make somebody else the new standby, and the life will go on. All right, and the life will go on. All right, so this is how the name node is no longer a single point of failure. All right. Also, this might look like that, okay, since we have two name nodes, why don't we send the request, some of the read requests to the standby? No. No request is sent to the standby for reading or writing the data. Client does client basically does not get data or does not update standby, does not try to take the decision based on the standby. Okay, standby is just the backup. There's no standby does not come into the action, doesn't come into the interface unless the name node is down. Otherwise what would happen is that there will be a delay, there will be an inconsistency. If a user has updated name node and b user has updated something else, or b user is reading from standby, now there will be a delay in which the information reaches from name node till the standby, and therefore there will be inconsistency during this period. All right. So, Bala, was I able to answer your question? I will make the notes here, and these notes will appear in your class. All right. 18th October Hadoop, 17th October evening. All right, great. If so, okay, Sridhar, I think your question is also answered. Your question is related to, all right. Okay, your question was who is responsible for increasing? It's still manual. All right, this is answered. There's another question from Arjang. So the problem here is that an admin node will be the bottleneck. So we answered two questions. One is why admin node will not be the main bottleneck, because the main request, for most of the requests, the admin node is bypassed. Okay, the actual data access. So Arjang, is your question answered? Yes, great. All right. Now question from Randhir is it configurable chunk of block? Yes. You mean to say whether 128 MB or 64 MB is configurable or not? Yes. All right. So you can configure it from the admin interface. Do not, when I'm showing you the admin interface, do not forget to, remind me to show you this part. All right. Now, serializing and deserializing, that's another question from Sushant. Serializing and deserializing of data is also time consuming, or will it require every additional buffer memory? No. Okay, so in case of file systems, you don't need to cache all of this information. You are just appending the data. You are not doing any conversion from object to the bytes. What does it mean by serialization? Serialization means that you have this beautiful object. Let's say my name is Sandeep. Now converting this into a serial format such as like this, okay, something of this sort, and that too in the form of binary, okay, is going to be time consuming process, but it doesn't do that. HDFS does not know anything about what is inside the files. It doesn't care as to what is it that you are trying to store or what is there inside your file. Okay, it doesn't care what extension your file is carrying or anything. It ruthlessly cuts them into the blocks and put them into the place. It doesn't care whether while cutting the blocks it has cut in between the line. In case it's a multi-byte character, it doesn't care that it has cut the character into two. Okay, it just cuts it ruthlessly. All right. Now, you might wonder that in case when we talked about the block size, in case we have, all right. So I'll try to answer your question more as you go ahead. There are a few questions I would like to ask, but after answering all your questions. Does that answer Sushant your question? Now, okay. This is the actual question what he wanted to ask. Breaking the large file into chunks and putting them together is not time consuming. No. Breaking down the file into any logical format is time consuming, but sequentially, no. So you just keep on reading data from left to right and keep on cutting it and sending to various machines. It's actually faster because the main time it takes is in the writing, right? Reading is faster than the writing, is 10 times faster than the writing. Therefore, when you are breaking the file into 10 parts and parallelly writing 10 on 10 different machines, it will be 10 times faster. All right. There's another question from Sridhar. Is partition of data done by HDFS, or we can mention partition technique? No, it is done by HDFS. You cannot mention the partition techniques. Okay. While reading the data or while trying to process the data, you can mention the strategies to assemble the data. That's another thing. We'll talk about that in when we talk about MapReduce. Okay. Right now, there is no partition techniques. There is a straightforward splitting into blocks, ruthlessly cutting the files into blocks. That's it. All right. All right. Very good set of questions. Now, question from Sridhar is, what about cost included for replication factor? Yes, I agree. I agree that for for 100 terabyte storage, we have to build we have to build 300 TB store, okay, and even more. Okay, so what happens is on these machines, if you look at it, one block is getting copied at 3 times, right? And on every data node, you will have only 80% of the disk available for HDFS and 20% dedicated to the single machines. Okay, So let's do a computation. Let's say you bought 100 machines with 1 TB each. Okay. Now 80% of this is how much? 80% of this is 80 TB. Okay. Now out of 80 TB, we will only get 80 TB by 3, which means you can only store how much? Uh, okay. This much TB of data. So out of 100 terabyte, you only got 26 TB. But this is a fair price to pay for all that you are getting in return. Does this answer your question, Sridhar? Yes. So when I say 100 machine into 1 terabyte, okay, 100 machines with 1 TB each. This is what I meant. All right, which means 100 TB. All right, Bala. Good. Now going ahead with next question. Next question from Bala is is there a configuration setting that will bring the value from 2 to 3? Yes. At any point of time, you can change the replication factor from of individual file, or you can also iterate over all the files, apply this replication factor on each file, and it will start rebalancing. Also, one important thing I forgot to tell you, that no two copies of the files will be on the same data node. Okay, there will be no two copies of a file on the same data node. All right, which means that if you have three data nodes, what is the maximum replication factor possible? Can you have a replication factor of 4? Yes, anyone? Correct. No, right? Similarly, minimum number of nodes in HDFS is generally, because as I told you that it is good to have a replication factor of 3, the dangers we talked about. So therefore, if you want a replication factor of 3, then you have to have 3 as minimum number of nodes, and one node generally dedicated for name node, therefore 3 plus 1. That is the smallest cluster you ideally should have. All right, great. Let me go through the questions one by one. Now, next question from Srini Is it possible to configure different data center hard drives for replication? High secure. So this is some algorithm which is taken care by HDFS itself. The first copy of your data is on the same, same Almira. Okay, and the third copy is generally off the rack. Almira, I say, is called a rack in which you basically mount multiple computers in the same network. So every rack is a local small network, and racks are connected in the data center to form the data center, right? So for first copy of your data is on the same machine from which the data is being copied. Okay, so near to the client is what where goes the first copy. Second goes in the same rack but not the same machine. Third copy goes off the rack. All right, so that algorithm is there, and all right, and always it takes care of sending the third copy as far as possible. We will talk about data locality and how to configure it at later point of time. All right, next question. To To simply name node and data node, can we consider them individual machines, individual servers with the hardware storage? And yes, so this is how you can think about them, but they are essentially processes. Okay. All right. Next question from Bala is, you mentioned if one node goes down, the system will automatically do the replication once it's back. Do we need to set? No, we don't need to. So as soon as one node goes down, immediately the copying will start happening. So the lost block will be recovered. Out of the three copies of a block, one copy has gone down. The copy has to be brought back to three. Okay, they have to be three level. Whatever is the promised replication factor that has to be bounced back, and therefore the automatic replication will happen. I'll show you this sometime. All right, next is breaking. Okay, so this I have already covered. John Ives question is map logic run on the block? If so, uh, then the data would be corrupt. Yes, very good question, and I'm really happy that you asked about it, but I'll not answer it right now. This we will answer in the third session. All right, it's a good question. All right, now what about cost included for replication factor? Now, quickly, John, in case you are going a little impatient, I'll just answer it here. So, yes, when the map project is run on individual block, the data might look corrupted, and that's where input input formats come into play. Input formats make sure that the data is written and logically interpreted by assembling data by doing the minimal amount of transfer amongst network. What about, so we have already talked about this, Sridhar. All right, so was I able to answer this question, Sridhar? Good. Now, question from Sridhar is communication between client and driver and the name node two-way? Yes, because name node, uh, so it's always like name node doesn't talk to people. People go and ask name node. People go and tell name node. So name node doesn't inform the client back. So it's mostly like one way. All right. Did I miss anybody's question? Susan's question is, here it is. The question is, what is meant by primary node goes down? So could you reformat the question? I'm not able to figure it out. All right. So Sushant, could you just repeat the question, please? All right. Now going ahead. Here it is. So what is meant by primary node goes down? It is the data that is indexed. As we have replication factor, we cannot transfer this index metadata from one to other and make the other node as primary. We can make. So I will tell you. Okay, let me go back and try to explain again. Look at this. This is our name node. Name node contains metadata. Metadata means which file contains how many blocks and where are those blocks. What is the replication factor of individual blocks? That is the information this name node is carrying. And the okay, so standby. If this node goes down, the copy of exact metadata is kept in the standby. And even if this goes down, the information is available here, and this will bounce back into becoming the name node. All right, Shushant, was I able to answer? All right. Now Veena's question is, where will the HDFS be physically located? It will be located on individual nodes. On individual machines called data nodes. Okay, the data, there will be a folder on these machines. Okay, there is a machine, this is a physical machine containing a folder dedicated for HDFS. In this folder the blocks will be allocated. Blocks will be individually like a big file of 128 MB each, except for the last block where the file will be smaller. Now this data node will this data node, or you can think of this as a machine, it will have one folder dedicated for these blocks, and these blocks will be saved as individual files. All right. Yes, Bala, that is more like an active passive. So Randir's question is, does the name node keep track of replication? Yes, as well as it keeps track of node going offline. If one data node does not give ping for some time, the name node goes restless, and it after some time it assumes that the data node is dead and immediately informs other data node holding the same blocks of information, and it informs data nodes to start replicating to create one more copy. Veena, does that all right? So Veena, don't worry about the input format. We will talk about input format again in more details because that requires a lot of more information about the computation. That is more related to MapReduce. We will talk about it. Do not worry. I don't want to confuse you at this point of time. Ravi's question is, once we read the blocks of file, who connects the files together into the final file? So here, so that this client driver does that. Client driver assembles those files and gives back to the individual user. And as we told that since it's not really combining files, it's basically just putting the files back to back, and that's what it is. So stitching the file is not that big a deal, okay? Because it's not really stitching, it's just putting back to back. It's not doing any extra operation. Now, Sridhar's question is a follow-up question here. The question was, is it one way? And is the font visible to you? Let me increase the font size. Once we read the blocks of file, who connects the file together, that we have answered. Going back to one question, is the communication? So here is the answer. But if it is one way, how client will know which data node is available? Okay, so client will always go and request the name node, and name node will reply. Okay, name node will reply. And replying does not mean that it's two-way communication, as in name node never calls client goes and talk to name node is a service running happily, either client comes or don't come. Does that answer your question, Sridhar? All right, here is a good question from Praveen. Question is, when a new data node is added to HDFS, how and who takes care of uniform distribution? I'll try to explain from here. Let's say we are adding one more data node to our cluster, which means we are informing name node that, hey, you got one more data node to take care of. Suddenly, when name node realizes that, okay, we have got one more data nodes, it immediately informs the other data nodes that please start copying this block to this block. So it will inform data node 1 to start copying this block to this block to the final node, and a second node to copy different blocks to the new one, and third one to start moving the blocks. So basically, name node does the computation of which blocks need to be moved. The actual data movement is done by the data nodes. All right. Does that answer your question, Pavan? All right. All right. So, John, I have answered your question. I'll repeat it. Probably you missed it. So let me try to repeat it. Okay. All right. Before that, there's a question from Randhir. So, does name node keep track of three copies of replication and make sure there are three copies when the node goes down? Yes. All right. All right. Yes. So this standby and the active server behave like active passive. That's correct, Bala. Can you have multiple folders for HDFS? Yes. Okay. So what OS can these data nodes have? Whatever they can run all Windows, they can run on Linux, as well as they can run on Mac OS. But they all need to have same OS. Okay. Follow-up question from Pavan. So does name node has the information about blocks, or just the files and the replication factor? No, it does have information about blocks. All right, it does have information about blocks. All right, here is a good analogy from Sushant. This is similar to clustered index and non-clustered index in database concept. Is there a problem of updating these indexes after every write? Yeah, you can think of it this way, or you can think of it like uh, there is a FAT32 in which FAT32 keeps a mapping between various blocks of file on the disk. All right, now let me try to answer John's question. I think John missed my response. So each block. Okay, there was one more question from John. Let me also pick that up. I'm missing it. All right, great. So question is map code run on the data nodes block? Yes, that's very good point. If so, then the data would be corrupt. It might look like it's corrupt, but there is an idea called input data format. Input data format is something which is a logical representation of data. And to prepare this logical representation of data, there might be a slight transfer of data involved while preparing this logical representation of data. All right, we will talk about it in greater detail, and how to go about preparing your own custom format is also we talk about. All right, it's a little deep topic. I'm happy that you have come up with this kind of problem, so we will talk about it in details. All right. Now, the second question, each block are written as a file. So there will be so many file in the node. Yes. There won't be so many files because if you imagine that one file means say 128 GB, 128 MB. All right. Generally. So yes, there will be so many files. You can say that. Now there is a good question from Veena, and files are split into a chunk of 128 MB block. What if the file size is 128 MB? Will it split as 128 plus 1? If so, the rest of 127 in the file will go unused. Okay, so when I was telling you about block, and I was telling you that actually each block will be stored as a file, right? So out of 129 MB, there will be two blocks, and two blocks, one will be 128 MB. There will be a file called the where HDFS slash, inside HDFS there will be blocks and so on. Under that there will be a block ID, and here there will be this will be you can think of block ID like something of this big number, and this will be of 128 MB size. This is a file. Now there will be another file of 1 MB size. Okay, that will be also something, another number. All right, so I'll show you this later point of time, but for time being there is no space getting wasted. The second file actually is of 1 MB size, second file which is representing the block in the file system, because at the end of day when you split these files, each block is going to be stored in the disk in the form of a file, and this file is not of 128 MB, it is of 1 MB. So there is no waste of space. Generally, when we talk about databases, they reserve they reserve the space for record, so that in case we are inserting more data, there is a space. See, this question is logical representation encryption. Yes, we will talk about those ideas. All right. Now, next is when data replication happens. All right. I'll take this question and then we will take a break for 10 minutes and then we come back and continue our discussion. All right. So when data replication happens, is it happen when file is uploaded into HDFS based on replication factor, or when one of the node goes down when the client requests for data replication? Okay. So first of all, as soon as you upload the file, okay, as soon as you upload the file, all blocks are replicated. Okay, immediately there will be three copies. All right, there will be three copies of individual blocks. All right, now in case any of these computers go down, all right, how should I draw? Let's say that there was a big file which is broken down into three parts. The last one I'm making it smaller. The and there are say three nodes. Okay, four nodes. All right. I will make nodes of different color. All right, and so this is one node. This is another node, and there is the third node, and there is the fourth node. Okay, these are the fourth node. All right. Now initially, it will happen in this manner. One copy goes here, one copy goes here, and one copy goes here. All right. Then one copy of this one goes here. Okay. And the second copy of this one goes here, and third copy goes here. Okay. Now, in the same way, there is one more, and okay, we are placing it in a way. Okay, so here there are these three blocks kept in these three nodes. Now uh, and maybe this one is here, or let me try to make it a little nice. Let's say uh, maybe it is of this form. Now what happens is, in case in case, let's say this node goes down, right? This node goes down. This node went haywire. Okay, let me just do this. Okay, which means this one, this block has got only two copies. One is here, other is here, right? It has got only two copies. We need to have one more copy, correct? And therefore we, one of these nodes will be communicated that, hey, keep one more copy on this node. Okay, so one more copy would go into this node. It looks little awkward because it's not fitting. Let me make my node a little bigger. Yeah, now it is fitting. All right, and also this has gone bad. So we'll find out, okay, this computer is having one of the node. Let's bring it here. Now does that answer your question, Veena? Srini? All right. There is a very good question from Sridhar. And all right, can we alter data stored in data blocks in there only? No. So HDFS does not allow you to alter or change the data. Mostly, whenever you are modifying a file, it is equal to creating a fresh new file and destroying the old one. All right, good. So we'll take break for 10 minutes. Back by 10:21 p.m. IST. All right, so I'm back. Should we start now? All right, great. So Bala's question is: the name node decides the copying of blocks when the data node goes down. Yes, that's correct. All right. So I hope I have answered your questions. All right, is everybody back? Should we start now? Great, great. So I only got yes from Bala and John so far. All right. All right. So we talked about the general architecture, how files are split, how the name node and data node works, and we also talked about primary, secondary, as well as name node and standby node. All right. We went into the whole flow. Also, we talked about this part. One more thing is in case of HDFS 2.x, the in 2.0 there is one more idea that has come up called HDFS Federation. So there are many things which we want to talk about. One is name node is a single point of failure, right? The way we have avoided it so far is first keeping keeping metadata in memory, metadata in RAM, second, so that it can respond quickly, delegating 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 most of the works to data nodes. Most of the actual heavy lifting is delegated to the data nodes. Second, by having primary and or you can say by having standby node. Okay, standby. All right. Now, still, still, what will happen is the more number of files will we have, more number of files, the more metadata would be there. Imagine that there are thousand files with 10 bytes each. Okay, which is equivalent to how much? Which is equivalent to 10 kilobyte. Okay, or you can say 128. You can say a million file with 128 bytes each will be equal to 128 MB. Okay, so 128 MB file and these many files store equal amount of data, but these files will have 1 million times metadata consumption. So one file consumes, uh, I mean, one block consumes that amount of metadata inevitably, because whether a block is bigger or smaller, the metadata will be of the same size. So if you have too many small files, then HDFS is not good. if you have too many small files. Therefore, what people do generally is, if they have too many small files, they generally create another format like a zip or a tar, which they push it to the network. Okay, we will talk about the splittable tar formats or splittable zip formats, where which can be easily split into blocks, and individual blocks can be uncompressed. Okay, so those are the few things. And now if you notice that after some point of time, name node's memory is going to get full, meaning it will no longer be able to keep all the data in the memory. Then what will you do in those cases? If you have hundreds of petabyte of data, which means zillions of files. Now that will overflow the name node. So to be able to handle those situations, HDFS 2.x 2.0 came up with this idea of federation. Federation as in, there is a client library containing the information that slash my data is on name node 1, slash my data 2 is on name node 2, or maybe slash my data 3 is on name node 3. All right. So basically, you create these mappings the way, if you notice that this way we are going backwards to the old style of doing things, where we created multiple folders and we are putting it. Not much, because here name nodes are not going to be many, and this circumstance is only in exceptional scenarios. Okay, where name node's RAM is not able to uh, accommodate all of the metadata of data nodes. All right, in those cases you can go for HDFS federation. Okay, so let's say, let me say again. So if you are trying to store a lot of data, and you realize that your hard disk is getting, your name node is getting full, its memory is getting full, so you come up with the idea that, okay, these are the 5 folders which we have a top label, and we divide them amongst the name node. Okay, so whenever a client request comes for some slash my data folder, or slash my data, or slash, let's say all the request for slash my data slash x slash y, and my file dot txt, if the request is coming for this, the request goes to the first name node. And if the request comes to any file underneath this folder, the request goes to name node. That's what is known as HDFS federation. All right. Basically having multiple name nodes. So everything which has to do, say you want to write to into this folder, or you want to create any file within this folder underneath anywhere, and so on, with all the requests will go into name node 1. Sounds good to you? Yes, all the metadata relate, all the requests that are coming to the files under this particular folder. This is top level folder. Okay, under this, any request for any file or folder goes to the name node 1, and this is decided by the client library, the driver, with so to speak. So driver will know something called mount tables, and mount tables it will read only once. It'll keep reading. And yes. Okay, so Veena's question is, where is the information stored that my data is for name node 1? That is stored with the client library, and it's basically in something called mount tables. All right. Sushant's question is, will name nodes, very good question. I was about to come to that one. Will name node 1 and 2 will the same set of data nodes? Yes. So basically, name node 1 and name node 2 will share the same set of data nodes. They will not be a kind of an island of nodes. Okay, they will share the same set of nodes. Brilliant question, Sushant. Thank you. And yeah, all right. So again, coming back to what is name node metadata. Metadata is in memory. The entire metadata is remains in memory, means RAM. RAM is a price, very fast way of reading data, and but it's quite costly. Also, in case machine shuts down, anything which is there in the RAM goes disappears. Okay. In case machine shuts down, the memory disappears. So therefore, the metadata is also capped on the disk in the form of in the file system. Okay, on demand, the paging of metadata keeps happening. Now, the types of metadata could be the list of files. Okay, the metadata which is there in the name node would have the information about what are the various files, what are the folders, and what are the list of blocks of each file, and list of data node for each block, and file attributes, and file size, file name, directory name. Okay, so a quick question to all of you. Now that we have understood name node and data node, I'm going to ask a simple question. If I'm trying to create a directory, okay, involves creating a directory involves A, name node, B, data node, C, A, A and B both, name node and data node. Okay, when we create a directory in HDFS, does it include only the name node, or it includes the name node and data node? All right, so I have got only one correct answer so far. All right, good. So the correct answer is A, name node only. Because when we create a directory, it doesn't have a data, it has only metadata. All right, good. So Sushant got it right, and Ravi also got it right. Good, brilliant. Now, so is that clear to everybody why the answer is A? Because when we create a directory, we are not writing the data, because data node knows nothing about directory. All right. Now there is also something called a transaction logs. Transaction log is basically it records the file creation, file deletion, and everything. Randhir is saying but data node saves file in the directory. So that directory in which the data nodes are saving the files has nothing to do with the actual directory user is asking for. They have their own directories. Okay, say I mean your HDFS could have a file saying my data, under which there'll be a Randhir folder under which my document.txt. But in case of data node will look at it like slash slash var slash HDFS slash blocks and then a big number dot, and this is where your data is going to be stored. Make sense, Randeep? All right. So now we will do a couple of things. First, we will go over. I hope I have answered everybody's question because there are so many questions. I might have missed your question. So if I have missed your question, please feel free to ask it again. All right? Because of the scrolling, I might have missed your question. Brilliant. So this was about the name node and data node. Let's do a little bit of exercise and understand the structure of our HDFS nodes. Okay. Now, in case those people who are not able to see 17th October, I'm going to paste the login and password to you over here. All right, so I've copy pasted the login slash password to all of you, and I will one by one we will go over the details. Yes, so Srini's further question is, does Namenode contain security information such as the file permission? Yes, you can see that in our discussion when we say that the access time and file attributes. File attributes is what governs the access permissions. All right. We will show you that there'll be some files which you cannot write to and which you can only read from. So that's another information available on the file system. All right, now let's go ahead and first have a look at our cluster. So Ambari, which is running on h1.cloudxlab.com colon 8080. So cloudxlab is a product of ours which is being used by many companies. So it's a cluster which is shared between multiple people. All right, so and I mean, we are increasing more and more hardware into this cluster. Okay, so right now this CloudX lab goes with various names with various people, and we are the one who came up with the idea of Cloud Labs. All right, we take pride in it. So this is Ambari. This is a standard tool to install. Those who are interested in installation, they can actually go with this HDP Ambari. Where is that? All right, I'll send you the details. I'll mention that in one of the documents. So there is, the idea is, let's say, I will just describe it using this diagram. Okay. So let's say you want to install Hadoop in your organization. So what you do is you buy these machines. Okay, so generally the way you do a little bit of planning, as in you pick up the machine with bigger RAM. Okay, bigger RAM. Okay, and then you pick up the machines of smaller RAM. Okay, maybe, okay, smaller RAM but bigger hard disk. So this is the other node. You generally put name node on this, okay, and data node on this, which have smaller RAM. All right. So I'm answering Srini's question. CloudX Lab runs on Hortonworks data platform. We have tried Cloudera. We realized that it's the same tools. It's just that their installation was something which has to run from the command line. It was not browser based. so we could not give a great demonstration to our student, unlike this one, the way we have this beautiful installation which shows that what is going on with the cluster. All right. So again, now coming back to what we were discussing. So the way it happens is, let's say you are buying a fresh cluster. So you bought these four machines. So on one of the machines, you will install Ambari server. Okay. And then you will start installing Ambari agent. And this is very straightforward. All you need to do is, if you are on Unix, all you need to do is yum install Ambari server. We will share with you the exact documentation. It's not a big deal. So once you have installed Ambari agent on all of these, okay, Ambari is a provisioning system which helps us monitoring and administer our nodes. So we bought the blank machines, blank Unix machine having some operating system. But make sure that the operating system is same across all these nodes. Once you have done that, you install Ambari agent on all of these machines, and then you open Ambari server like this. Okay. Initially, there'll be nothing here. You go into hosts, and there will be something called admin. Here there'll be something called the add host button. Okay, I'm not able to show you add host button because I'm not administrator here. So add host button, you click on add host button, you mention the IP addresses of Ambari agent, and then you click next. Then you provide login password of these machines, and then you click next. And then it will ask you what service need to go where, and then it will install all of them automatically. It will download all the things required for that and then install on all machines. So you don't have to do that much deal. Now you can see there are so many services running on each individual machines, and we didn't have to do much about this. Everything was taken care by Ambari for us. All right. So in case you are interested, you can use Ambari. I really like Ambari server, this whole cluster. Okay. Now we have HDFS. There are three data nodes. Okay. Three data nodes running on these three machines. All right. H1, H2, and H3. All right. Now we have name node and secondary name node. Name node is running on this machine. Okay. 22-91, and secondary name node is running on different machine. We don't have the high availability setup here. We only have the secondary name node. Now, the next is the data nodes. These are the data nodes on all the machines. So you notice that the name node and data node are on the same machine, which is completely okay. There's nothing wrong in having name node and data node on the same machine, because data node do not consume RAM while name node consumes RAM, and name node doesn't consume disk while data node consumes disk. So it's okay to have name node and data node both on the same machine. It's just going to overload a bit, which is completely okay for our kind of setup. All right. Now, in this, you can change the config. If you are an administrator, you can change the config in various form. So you can say, go to advanced. If you have the permission to edit it, you can change the block size from here. Okay. I'll show you block size. Where is the block size? These are, we're talking about HDFS, right? Yeah. Yeah. You can see the default block replication is 3. Okay. And the reserved space for HDFS is this much. Okay. Per volume, as in if you have multiple hard disk, this is going to be the one. And we can also go with the percentage part. Next is the block size. Let me just find, there is a block size somewhere. Okay. Okay, there will be a block size. Okay, so this is general. It says that reserved space in bytes per volume. Always leave this much. Okay, that's okay. And checkpoint, NFS gateway. Okay. So one of these settings have advanced HDFS, right? Yeah, you can see that. This is our block size. Okay, this is our block size, which is in bytes. So you can change it to your. So when you change the block size, the older blocks will also, uh, you know, so when you change the block size, older blocks will not be touched. Only the newer blocks which are coming in will be modified. So if you divide it by 1024, again 1024, it comes to 128 MB. All right. So and these are the heartbeat levels, showing that the every time it will keep on sending the heartbeat to all. I mean, all the data nodes will keep on sending the heartbeat to Namenode. All right. All right, now coming back here, the question from John Ape is that how is Ambari different from Hortonworks virtual machine? Okay, so Ambari is same in Hortonworks virtual machine. Hortonworks virtual machine also comes up with Ambari. Okay, it's same. So virtual machine is a collection of all the services installed. Ambari is just one service which helps us install everything else. It helps us, Ambari helps us in installing, helps us in monitoring, and helps us in changing the settings. Next question from All right. Next question from Bala is, for the sake of practicing installation, can we install both Ambari server and Ambari agent on the same machine? Yes. All right. So Ganpati says that for all the parameters mentioned in the settings, is there explanation document? Generally, you have to take the cursor here and it should generally show you that what does each property do. Okay, or you will have to look it up. Because this is not an administrator course, so you'll have to a bit figure this out by studying a little bit more. All right. So we'll go into the details on how do we operate on each of these. So this was our administrator interface. Now second is the Hue login. All right, we will see what's going on with this. Doesn't require, yeah, let me just log out from administrator, because in administrator you have all these accounts. And how do you log out? So this is a newer version of Hue, the latest version of Hue we have installed recently. And let me try to, do you see, and does anybody see a logout button anywhere? Yeah, there on the last one. Actually, the button was hidden behind my GoToWebinar. Let me try to copy paste the login password. And yeah, I'm avoiding showing the password because the video is getting recorded. All right. So here you will see all. So this is Hue. So Hue provides you a web interface to almost every operation. So you can basically do everything using Hue, starting with talking to HBase, talking to Scoop, Zookeeper, and also creating workflow using Uzi, and also talking to Hive, talking to Pig, talking to Spark, and everything. So everything you can do from here itself. Now let's talk to the file browser. Okay, so file browser is nothing but HDFS file browser. This is our beautiful file browser. Okay, you can go up or you can travel anywhere. You can see that this is our file browser, and under this almost every application is going to store its own data. You can see Hive and HBase and Accumulo are also storing the data in HDFS. Now under user, everybody has got their own folder. You can see that everybody has got their own folders, and that's what is going on here. Now coming back to our home folder, here you can create your own folder. Okay, this user will change for your individual accounts, and another different ID will start showing here. Okay, till then you can keep on using this. You can create your folder. Okay, you can upload a zip file, you can upload a normal file, or you could create a directory. Okay, let me create my own directory. Alright, most of the data that we require for this session will be available in this data folder. Alright, now the folder for sgiri has been created here. Let me just try to upload some file into it. Okay, so using this upload button, I can upload file from my local hard disk, and let me try to upload yesterday's video, but that will be too big, and so let me just upload something which is little bigger than um, I don't have much with which is bigger than 128 MB. Now you can see that actually the block size is big. Okay, I cannot upload this video, it's a little personal. And alright, so do I have something here? Alright, no. So the only best bet I have is this Eclipse. Oh, it's not working. Or maybe it's working. So Naveen Gupta's question is, can we access shell Unix prompt? Yes, I will show you that. Alright, good. I'm happy that you want to access it directly, and I rarely find such users. Alright, so it's not okay that I'm yet to select a file. Let me just select this one. This is 90 MB file. It should not take much time. Good. So Ganpati's question is yes. So when you are uploading these from your local machine, where is the destination? And behind the scenes, the file is getting splitted into 128 MB blocks. Okay, so where is the destination? Destination is HDFS, and HDFS is basically, as we told you, the file system is divided into multiple systems, and behind the scene is replicated and broken. All right, so this file is 50% uploaded, and what's happening is, since it is 128 MB, it's not being broken. It's only one block that is being copied on multiple machines. Okay, and if we had an Ambari open, we could actually see that it has consumed thrice amount of storage. Vina's question is, can we upload only one file at a time? Is there a batch upload option available? You can upload the full directory into HDFS from the command line. Okay, in case you want to upload multiple files, what you can do is create a zip, and then you can say upload a zip file. Okay, if you upload a zip file, it will break it down automatically into the folders. Okay, let me show you. So for example, there is this KeyPass software, which being 2.4 MB, has it's in the form of zip. Let's see if it gets broken down into multiple files. So you can see that it is a big folder containing all the data. So we had zipped it, uploaded it, it was uploaded as a folder. Alright, let me just delete it. I call it move it into trash. So this HDFS provides you a trash kind of option, which is basically nothing but a folder called .trash in which all the files are moved. Alright, let me, yeah, that's a good idea. Let me also try to open Ambari. Yes, it would be internally splitting the data into 128 MB automatically. Alright, so here we are, and so here the disk usage would have gone up by a little bit. Right now it's 6% disk usage. Alright, basically these are three machines, each with 200 gigabyte and out of 560 GB. Okay, and we are utilizing only this much amount of storage. Okay, sounds good to everyone? Susan's question is that, yeah, it's a good question. I wouldn't say it's irrelevant question. As all the data is stored on machines, if something goes wrong with all the data, is there any backup measure? No. In case all the machine go down or the whole data center is on the fire, then you can't do much. Unless you had another data center connected together in the HDFS on which the data is getting copied. All right. In those extreme case scenario, even cloud also has, okay, the problems. Now question from Srini is, can you show the metadata for uploaded file? All right, good. Now this was how we interacted with the file system from the browser. Now let's go with the terminal. All right, so we are copying these files directly into HDFS. Okay, directly into HDFS. Coming back to where we were, Now let's open something called console login. Console is available on all the hosts. You can directly open h1.cloudxlab and you can start. So Control Shift V is for you to copy to paste. Control Shift V if you are on Windows. Okay. If you are on Mac, you can simply say Command V and it will paste. Okay. And you can also open multiple terminals. So here this is our Unix shell. This is the individual control of these machines. Okay, so right now the account is different for different people, and here I have already put some folder called SS. Now let's first try to interact with local file system. This is our local file system, and here there is this folder called uh, SS. It is my folder which I created earlier, and these are the various files which I had created locally. This is the local file system of H1. Similarly, there will be another file system for H2. Now if I open H2 here, you will get the difference what I'm talking about. Okay. All right, so we can say ls here. Now the folder structure here is different than this one, but when these two machines interact with Hadoop, the folder listing you will get is using the command called Hadoop fs and ls. Okay, so Hadoop fs minus ls shows the listing on the server. So Sridhar has created a folder there, and he has uploaded it there. Since we are all using right now the same account for demonstration purposes, therefore we are all able to see that. There is no file inside Sridhar folder, therefore there is nothing. Alright, now let's try to do few things here. If you go to the second machine and say Hadoop fs ls, the result will be the same because they are all interacting with the same file system. All right, so let's see if Sridhar has uploaded a file in this. Not yet. All right, now here if you can see that we have created, we have this local file system in which there is a different set of folders, and there is a common file system which is HDFS, which is same for all of this. So Hadoop is your client driver. When I say Hadoop FS, this is the guy who we have been talking about so far, and this is the guy responsible for most of the communication with HDFS. Sorry. Now now, if you want to know what are the other options you have for copying for various file system, it is there is a lot of commands that are available. All right, there are a lot of commands that are available. Let's have a look at it. There's append to file. If you just want to append to an existing file, you can use this command. You want to see what is there inside a file, you use get command. If you want to see what is there in the file, if you want to create checksum, if you want to give permissions to various users on the file, then you use chmod, chgroup, chowner. Now, the most important command out of it is the one which concern us right now is copy from local and copy to local. If I want to copy the data from here in this folder into my HDFS, so I'll use Hadoop fs minus copy from local. Okay, and I will pick up one of the files or maybe more files. Okay. All right, so I'll say this, and then I'll specify the remote folder. And what is our remote folder? I'll just say the dot means current folder. Now it's copying the files into the file system. Now if you go here and click on refresh, do we have refresh? Alright, so where did it copy? Yeah, it copied into the outside one. We can either delete it from here, or we could also have done a little more sensible thing by moving these files into our own folder. Alright, let's try to say, instead of saying dot, we will say asgiri. So this asgiri means the remote folder in HDFS. Alright, so here we go. Now the files have been copied here. Now if I want to, uh, let's see, okay, I was just waiting if Sridhar upload some files. Okay, never mind. Now let's say I want to download. So this is one terminal called H1. So on H1 we uploaded from H1 we uploaded the files, our local files into HDFS. Let's go to H2. Okay, H2 is another machine, totally separate machine on which there is nothing on the local file system. Okay, you can see that these are all hidden files. There's nothing on H2, right? So here also, if I say Hadoop fs minus ls and I say asgiri, give me the list of files inside asgiri folder, I can see that there are these files. All right, now let's say I want to copy this file to local. I'll say Hadoop fs copy to local and this file name. All right, now yeah, it has copied. I don't know why it's giving the error that HDFS stream is already got. Okay, so we have been able to successfully download this file. All right, we can remove this. We are just removing our local file. We are not touching anything. All right, so this way we were able to download the file from the command prompt using from the HDFS. Okay, so we were able to download the files from HDFS to our client, to our terminal, to our local machine using the command line called Hadoop. Okay, so there are many more options in Hadoop. Explore those. If you want to know more about any of the commands, you can say -help. All right. If you want to know more about, say, -help, minus and text, that's one command. So it shows that the -txt takes the source file and outputs the file in the source format. If I want to see what is there inside a file, so I can say cat asgiri, and what was the file's name? I forgot to, yeah, let me just take the file's name. All right, so this is my file name, and you can also see what is there in the file by clicking on it, and that's how, okay, you can quickly see. Similarly I'm going to H2, not H1, and you can see Hadoop fs minus cat, and this is the file folder. Sounds good. We were able to read the file from remote. All right, by default whatever communication happens is happening between you and your home folder in HDFS. If you want to explicitly specify that I am copying the file from local to that particular folder, you can mention that as the second argument. All right, Naveen, so let's say I had put in, when I was saying here, this is the last folder. If this last folder name starts with slash, that means I'm specifying an absolute directory. But since I have specified a directory name without, which is not starting with slash, that means I'm talking about relative folder location, which is relative to my current directory, related to my home directory, not current directory. All right. All right, so this is how we get it. So Randir's question is, user is uploading file to the server and creating the directory. How to automate the processes? So the automation mostly happens through this command line, or there are tools like Flume, which we will talk about it at later point of time. Or the automation could also happen through Uzi, which we will again talk about at later point of time. So yeah, using the browser or terminal is an option, or is there specific things that can be done using through the console? There are many things that can be done through the console that are not possible using the hue. Okay, so using the terminal gives you the complete absolute control over what is being, what you can do. Okay, you can do everything from the command line. Okay, while you are limited by the functionalities which Hue is providing to you, and therefore it is always better to know how to use the command line. All right, great, great. So moving ahead, so almost everything is done through the command line. Okay, browser is only good for, only for browsing around. Okay, good. Now there were a few things which we have missed yet. We will talk about those. Where was that option? All right, it doesn't show you, although it gives you a edit file button with which you can edit a file. All right, now what I wanted to show you is, let me try to see if I can. You can change the permission from the browser itself. The permissioning system is exactly like your normal Unix. Okay, it has users and groups, and you can give permission to the group owner or others. Yeah, so Randhir, thank you for reminding me that. Let me have a look at it. All right, um, so let's go back to our slide. So the next objective we had was to know where exactly are our blocks. All right, let's have a look at it. Now when we say Hadoop fs minus ls and say ascii, so we have this nice file called layout desktop wireframe. Okay, we will give its absolute location. We will say what is the absolute location. It is this one. Okay, and we will say like this. Alright, you can connect to the name node via this URL. So here it is this. So it's saying that we are connected to the name node, and name node is running on 50070 port. Okay, we are saying HDFS. There is another command than Hadoop called HDFS, and we are saying HDFS FSCK minus blocks minus location minus rec. Show us. So we are saying file system check, give me the blocks, give me the locations, give me the racks information, and give me the files, the actual files, block files. So it's showing that it's connected to this particular name node, and it's using that URL. and then it says that file FSCK has been started by this particular user from this node for this particular path, and it shows that there is only one block. You see that? There is only one block. Alright? And the replication factor is 3. Alright? And these are the blocks. You see? These are the names of blocks. This is the IP address of the node. Okay, this is the block ID. You see, BLCK1002 and so on. This is the file size. This is another machine. This is another machine, and this is another machine. So these are the 3 locations of the block. Alright, next is that it shows you that what are the total number of blocks, what is the average replicated, the default replication factor, which is 3. Average block replication is 3, which is perfect, which is 100% replicated. There is no corrupt block, there is no missing replicas, there are total three data nodes, and there are 1 rack. Alright. All right. Now there is a good question from Sridhar. Question is, can we upload files from remote host? Now here we had command called Hadoop, right? Here we had a command called Hadoop. So we were able to upload our data happily, and therefore we were able to quickly do copy from local. So what if we want to upload data from non-Hadoop environment, meaning there is no Hadoop client installed? So answer is simple. You basically install Hadoop environment and a Hadoop command line, and inside HDFS site.xml, okay, you mention you mention your name node location. This is the name node location, and rest will this command will automatically take care of. You can simply say yum install or apt-get install Hadoop, and it will install the Hadoop client. All right. And in this configuration file, which is located in /etc/hadoop/this, you can mention the HDFS site. All right. So that's how you can upload. And also please note, when you are uploading from the distant file system and there are so many files to be copied, you use Hadoop dist cp. Don't use Hadoop FS if you have many files to be copied to Hadoop, because this CP takes care of distributed copy. It runs the upload in parallel on all files so that all the data nodes are involved in uploading rather than only one node. Very good question. Now, there is a question from Sushant. Can we load data from databases like Oracle Sybase? Once data is uploaded, can we eliminate these databases? So there are 2 questions. I'll split it into 2. First is, can we load data from databases like Oracle Sybase? Yes. Okay. You can simply load easily because all of these HDFS also provides you a Java API. Also, you could use Scoop for copying the data. And once the data is uploaded, we can eliminate these database engine. Answer is no. Okay, so database engines like Oracle, Sybase, they they have something which none of the big data tools can have provided: transactions and relational structure of the data. There is something none of these big data tools actually provide you. All right. So Sridhar's question is, can you show us install Hadoop environment and HDFS site? So what we will do is we will try to create a video instead, because installation takes a lot of time and you all will went off to sleep. Okay. So instead we'll just create a video and we'll send it across to you. All right. So Sushant, is your question, how can these help? As in, once the data is uploaded, can we eliminate these database engines like Oracle? So did you mean to say that once data is uploaded, do you mean to say that all the record updation, deletion, and SQL query can it run through HDFS, or do you mean to say that do if once the data is copied here, would we still need the main? Okay, the day when data get copied, you can access directly from here. Don't need to go to the Oracle again. All right. I think I'm misunderstanding the question. So first is that it's very difficult to eliminate Oracle and Sybase. Okay, mostly the you eliminate most of the data from these servers where you don't require the transactional behavior. Okay, so and for that you can use any of these HBase or others, right? All right, now question is, how can I query the structured data and add it? Quick answer is HBase. We will use HBase and we will show you how can you have millions of columns and billions of rows in a table and edit it and query it. All right. And about eliminating column based database engines, not really. Okay, the database engines are here for because they provide really useful things. Okay, so the idea is that as soon as you have a better column based engines, then you will use those. Okay, there is a very big benefit of having column based database engine. All right, Veena is saying, do you have a list of commands that are, you mean the Unix command or HDFS commands? Okay, for Unix, you can go with any basic tutorial. Any basic tutorial will help you with ls, mkdir, change directory, and maybe use nano. Let me check if nano is there or not. If nano is not there, we will. Okay, nano is there. Nano is a text editor, and we have ch mode, we have ch group, we have rm minus rf. Don't try these two commands please, because it will delete everybody else's folder as well, because we are sharing the same account right now. And so these are the Unix not common commands. In case of HDFS, you have generally the same command with fs. So you have mkdir, you can say uh, okay, so you can have ls, you have cd. CD is not quite useful here. Okay. And you have cat. Cat is another command you can keep in mind. And touch is one. Using touch, you can just create another this thing, and RM and so on. Okay, so you can try this. All right. So Sushant's question is is HDFS like a layer of organizing data on the top of data organized by Oracle and Sybase? So HDFS is just like a file system. Let's not get into that Oracle and Sybase right now. So right now we are building a file system. HDFS is a file system. Okay. HDFS is not competing or trying to be Oracle or any other database. It's a file system which is humongously distributed. Oracle is not humongously distributed. It runs on a single machine. Or any of the existing file systems, they are not distributed. They are stored on one machine. In case that machine goes down, everything goes down. Same way, so HDFS is just a file system. And what you're talking about is a database. For database, you run you run HBase on top of HDFS and on top of these machines running parallel. And we will go into this detail. This debate is probably far bigger than what we think it is. All right. As we go ahead with one component at a time, your ideas will get clear. But that doesn't mean the question is not important. Question is important, and as we go ahead with multiple components from now on, you will get the answer that when to use what. That is the main idea. All right. So So again, Randir's question is, how do we store structured data into HDFS? We don't. In HDFS, we store the files like in we store C colon, we store CSV file, or we can store the pre-formatted formats into the HDFS. All right. Sridhar's question is, instead of having data across multiple systems, why don't we go cloud? Okay. Okay. Why don't we go cloud? We are building cloud. We are building cloud. This is the cloud. All right. So it's not possible when you have data in the cloud. First, your organization would not like to move the data out of your organization first. Second, if you have to do the computation, you will have to do the computation on the cloud. All right. And most of these cloud systems are not really performant when it comes to churning the data in a humongous size. You will understand that after we discuss the data locality. All right. All right. So mostly this is what is underlying a cloud. All right. Because inside the cloud also the infrastructure is quite similar. Does it make sense, Sridhar? All right. Good. So uh, actually I wanted to, yeah. So also I forgot to show you that we could change the replication factor by some amount. All right. My Chrome has crashed. All right. Good that Chrome has crashed. Had I been using virtual machine, the whole machine could have crashed by now. All right. So good. That's pretty much for today. Please attempt your quiz and go through the quiz, and we will go into the details of MapReduce in the next session. All right? We will go into the MapReduce in the next session. So, Sridhar, the PPT is available in this. Okay? PPT is available here. If you are not moved in this, okay, so please let us know if we will make it available in this. All right, so PPT is available here. And quiz is also here. All right, quiz is also here. All right. These notes will appear in session 1 and session 2. The new recorded video will come here. This is the old video. We'll have to put the new video here. All right. All right. So you have to finish half of the quiz before the next session, and then we will go ahead with the second session. Actually, we only took up to here. We took only up to here. So you don't have to touch this assignment. You just have to finish the quiz and also make sure that you are comfortable with the file system. Yes. So MapReduce, you don't have to touch the MapReduce question. Okay, we have not started MapReduce. We are still talking about Hadoop architecture, Cloud Labs overview, and HDFS. All right. Thank you very much and have a great week ahead. So best way to clarify is just drop us an email on Hadoop at No Big Data. Okay. So best way to clarify is by dropping us an email at Hadoop at No Big Data, this one, and we will be able to answer your questions. All right. Good. Have a great day. I look forward for the next session. Bye bye.